I'm bad about remembering it. Anyway, back over here. There are recordings, or I'm trying to make recordings if I can remember to turn it on. So we have a recording from Monday. I failed to turn it on Wednesday. So someone that this is really, they want to see, then please just remind me during a session, hey, you can say, did you turn the recorder on? It should be giving you guys a message saying that it's recording or that it's going to record. But if you notice I haven't turned it on, please remind me because I have nothing here to really remind me of that. But anyway, to watch those recordings, as it is right at the moment, you would just click on this link here in the folder course materials, and then you would be able to play that. But I have found out that we have a limited amount of space in these Blackboard shells, so I have to download the recordings onto my computer and then upload them to YouTube, and then I'll give you guys the YouTube link. So eventually you'll see a folder here instead of this one item, and you'll be able to go into the folder, pick a date, and then you'll be able to go to the right location in YouTube to see those. And also there are transcripts of the chats, and those will be there to where you can download those if you want to look back through it for some reason. So anyway, I get that worked out a little bit more, I'll send you guys an announcement. So I think that is it on this stuff. I'll stop sharing my screen. So before we move forward, has anybody got a question about anything? Just raise your hand. Yes, May, what's up? You can talk if you want, but okay. Exam 3. All right. There will be one. I don't know exactly, so I can't answer you real well. It won't be Monday, that's for sure. It won't be Wednesday, that's for sure. Okay. If it's looking like it's going to be Friday, I'll try to get you guys a note on it. Okay. And also what it would cover. It's still going to cover what it would have covered had we have had it when we originally had it scheduled. I'll put it that way. So not this most recent stuff. Okay? Get that worked out, I'll let you guys know. Anything else from anybody? Yes, Ashley. Let's see. Oh yeah, yeah. The way that's going to work is when we do have the exam, it'll be during a class time. So you'll come in, you'll log in to collaborate, and then I'll send you back over to Blackboard, and there'll be a location where you click, and it'll take you to sapling, and then inside a sapling will be the exam, and the exams will be just the same format as the previous two exams. So it'll be like multiple choice questions, 5 responses. You click on an answer, you go to the next one, you click on an answer, you go to the next one. If you decide you want to go back, you can and change an answer, although that's usually a bad idea. Usually your first answer is the right one. And then when you're all done with all your answers, in this case, as opposed to everything else in sapling, you'll actually hit a submit button. And then it will ask to confirm, do you really want to submit this? Because you can't go back if you do. And then you click submit, and then after you've submitted, it'll show you the correct answers to everything. So that's the way we'll do that. But I don't have it ready to go, so there's nothing else to say really. Anybody else got a question? Okay. Yeah, Gary. Yeah, that's probably a pretty safe idea. It would be mostly on chapter 4. I mean, it's not going to be chapter 5 for sure. So no chapter 5. Okay. I mean, we'll talk about this more on Monday. Hopefully I can get it figured out over the weekend. Yes, you're welcome. Anybody else? Okay. In that case, we're gonna jump back into lecture. Uh, so we're in the thermal chemistry chapter. That's chapter 5. So let's go there. And okay, this is where we left off, was this whole idea of Hess's law, to where if you have um, if you know, say, the energy that is either exothermic or endothermic, going from, say, in this case, you're going from carbon solid, uh, yeah, going from carbon solid and oxygen to just carbon monoxide and half of an oxygen. So you know what the energy is. And then if you know the energy going from carbon monoxide and half an oxygen to carbon dioxide, so that's this other number. So if you know those two numbers, you could combine those together and you could get the energy that it would take to go directly from carbon and oxygen to carbon dioxide. Now that's the whole thing behind Hess's law. And then we did a worksheet, and I want to go back to that worksheet now for a second. And so if I recall, I showed you how to do these first two, and then we skipped question 3, and then we did questions 4 and 5. Is that a, if I don't have that correct, please let me know, somebody. Okay, so that's what I recall that we did. Now we're going to come back and pick up question 3, but we need to talk about a little bit more stuff. Something that's called enthalpies of formation. So we'll do enthalpies of formation, and then we'll come back and we'll get into question 3, and then we've got another worksheet on enthalpies of formation. So I'm going to leave this now. You don't remember 5? Well, then perhaps we didn't do 5. Oh, wrong one. Sorry. Okay. So, okay, so you're saying we did not do this. Oh, yeah. That's it. We all had different answers, and then we gave up and left. Okay. So, let's see. So the only one you guys did on was 4. Okay, I'll tell you what. I'll work with you guys, and we'll just sort of go through this. I'll call on some people, and we'll try to figure this one out. So anyway, we're wanting to calculate. Oops, my marker going here. Okay, we're wanting to calculate the delta H, or the enthalpy. This is enthalpy of reaction. So a lot of times they'll have a subscript. It's RXN for this. And we're doing it for this reaction over here. So remember that we can combine these numbers over here to get that, as long as each of the reactions that we have contributes to making the reaction that we don't know. So the way to approach it is to look for something in a reaction that's unique compared to the other reactions, and that matches up with the target reaction we're trying to calculate for. So, well, I'll tell you what, I can let my phone randomly select somebody, because I did take roll today. So let's try that out. Oh, hang on just a sec, guys. Okay. Okay, where is that? Okay, my phone is telling me that I should ask Ashley. So Ashley, on this first reaction right here, do you see something in the reaction that matches the reaction we're trying to figure out? You can either type that formula, or you can say it, whichever you'd rather do. Would it be aluminum? Okay. Well, let's see, folks. Do we see aluminum in any of the other reactions? No. So therefore, aluminum would be a good one to use. So we've got 2 aluminum solids here and 2 aluminum solids up here. Now I'm going to ask somebody else. Jesus, does it look like that the 2 aluminums in this reaction matches up well with the target reaction we're trying to solve for? What do you think? Yes, it does. They have the same coefficient. Well said. So they have the same coefficient. So that means that this reaction probably is going to work. So we can use it as it is. Now we're going to go to this next one. But we got a problem. We don't see any HCl up here in our target reaction. So maybe we want to leave that alone for a minute and go to the next reaction. So now let's consider this third reaction here. It's got hydrogen, it's got chlorine, and it's got HCl. I'll ask somebody. Lily, what do you think? Do you see anything in this reaction right here that would match up with our target reaction? Cl2. Okay, so she wants us to look at the Cl2. There's Cl2 here, and there's Cl2 in the target reaction. I'll ask somebody else. Ah, well, she's already got it. Hey, okay, thank you. So the coefficient is wrong. Up in the target, it's 3, and down in the reaction we're going to use, it's 1. So that means that we need to multiply this times 3. Yeah, thank you. So that means we're going to take over here, and we're going to multiply this value by 3. Now let's move on down to this last reaction. I'm going to change colors to maybe keep things a little easier to see. So we're going to look at this last one here. And it says Brenda. Hi, Brenda. Do you see anything in our reaction, that last one, matches up with the target at the top? Yeah, the AlCl3. So, okay, we've got AlCl3, and it's AlCl3 solid. And down here, we've got AlCl3 solid. But does it really match up? Is there something we would have to change to have it match up? Have to flip it and multiply by 2. Absolutely. So we're going to flip it and we're going to multiply it by 2. So we've got to take our number on the other side here, and when we flip, yes, May, go for it.
Oops.
Because, very good point to point out here, because, I'm change colors, here it's the solid, and here it's aqueous, but in the target, it's solid. So we need a solid on the right side instead of on the left side. Does that make sense? Yeah, okay. So that's why we're going to flip it. So when we flip it, we have to take the sign here and make it positive, right? So it's going to be positive 323. And then because we're multiplying by 2 over here, we've got to multiply by 2 for the value. So it's going to be 2 times positive 323. So now if you take the negative 1049, oh, sorry, got one more to look at. We're not quite there yet. That is the one we skipped. Is flipping the same as, let me think about what you just said. Hang on a second. Is flipping the same as multiplying by a negative 1? Yeah, that's true. It's the same as multiplying, because multiplying by negative 1 is going to change the sign. So in this case, a negative is going to change to positive, And if it was positive, it would change to negative. So yes, that is multiplying by -1. Thanks, Gary. That's a good point. Okay, so we still have a reaction that we've not done anything with, and that is the one we skipped earlier, the HCl. Now, there's no HCl up here in our target reaction, but there is HCl in some of the other reactions. You can see it's here, and it is here. So what we want to do is match the HCl in this reaction with those other two. Now, we're going to have to make sure that it matches them in the coefficient, and also, as we were talking about before, HCl gas on the reactant side, aqueous on the product side, those need to match up. So this is a little bit more complicated thing here, because we have to make sure that both of those are matching up. I'm going to call on somebody and ask them what they think we ought to do. So Paul, what do you think we should do with this? Multiply it by 6. So let's see, if we multiply by 6, then that will take care of this right here. So we could go 6 times, and now you'd have 6 HCl gas producing 6 HCl aqueous. The only thing, though, is will the 6 HCl aqueous here cancel the 6 HCl aqueous above it? Will those cancel? What you guys think? If you think it'll cancel, raise your hand. Let's do that. Okay, May thinks it will. Yep, 2 more, it says. Yep. Everybody's going for it. Okay. Yes, it will cancel, because you're going to have 6 HCl on the right side canceling 6 HCl on the left side. So that will cancel. So that means then I'm going to need to come over to the right side here, multiply it by 6. We're not going to need to flip, because the HCl aqueous is on the right down in the second reaction, and the 6 HCl is on the left in the previous reaction. So when you have something on the left and the same thing on the right, they're going to cancel each other. And we're wanting the HCl to cancel because we don't need any HCl in our target reaction. Up at the top here, there's no HCl, so we don't want any HCl left over. So anybody got a question on that? Yeah, May. Go for it, please. Oops, I messed that up.
Can you just explain more why we don't want the hydrochloric acid?
Okay. Well, it's not. I'll tell you what. I'm gonna erase, and let's see. Hopefully, I can get back to this. Okay. So up here, I've got 6 HC. Oops. Turn my marker on. Okay, I've got 6 HCl here, and I'm going to multiply this reaction by 6. So that's gonna produce, it's gonna have 6 HCl gas, 6 HCl aqueous. So these are gonna cancel each other out. And that's what we want to have happen because there's no HCl in the final reaction.
Gotcha. Thank you.
Okay. So, so now we're going to multiply this one by 6. And then the second one, we're going to multiply by 3. And this last one, we need to flip it or change the sign or multiply it by a -1, but we want it to be a positive 323. And also it needs to be multiplied by 2. So 2 here and 3 here. So why don't you guys take a moment and combine these values together. So we want to combine the -1049 with 6 times -74.8 with 3 times -1845 with 2 times positive 323. I'll give you a minute to do that, and I've got a text message from one of your fellow students, and I need to see what they have on their mind. Okay, I got it. Yeah, May.
Are we still supposed to add the HCl even though it's supposed to cancel out?
Mm-hmm. Because there's energy involved in that reaction occurring, so we still have to include it. Ah, Gary's got an answer here. Me too. Yeah. Okay. Well, I'll tell you what. Let's see what the key looks like for that one. So the answer is -6,387. So yeah, that's correct. Anybody got a question on how we did that? After we do question 3 on this worksheet, which we're not going to write at this moment, then I'll make this available on Blackboard so you guys can look at it. So I'm gonna get rid of this for now, and we'll go back into the PowerPoint. That's not the right place. Okay. Oh, sorry, I missed somebody's comment, I think. Or maybe not. Okay. So make this smaller where you guys can see it. Okay, so we just did this, and So this is Hess's law. And again, remember, the reason why we're doing this is for a situation to where we know some numbers, like maybe we, as we were saying before, maybe we know these two numbers, but we don't know this number. But we can solve it by combining those other ones together as long as they actually fit together. So that's why we went through the practice of that. Now, we're going to approach it differently in this next slide. We're going to figure out what's the energy for a reaction that we don't know by doing some calculations. But those calculations are going to involve something called enthalpy of formation. So here is enthalpy of formation. It's got a certain definition. What we're doing is we're forming something, and what we're forming is in this list over here. So we're forming O2 or H2 or C3H8 or CO2 or H2O. We're forming those, and the reaction to form them is going to involve the elements. Oh, can't see it. Interesting. Is anyone else not seeing the slide? Just raise your hand. Okay. Don't know why one person wouldn't be able to see it, but what I'll do is I'll go back and reshare it. And we'll see if that fixes it. Okay, Gary, can you see that now? The slide should be showing up. Okay, great. I don't know what happened before. That was weird. Okay, so anyway, these are reactions where we're forming something. What we're forming is in the list here on the left. We're forming them by combining elements that are in their elemental form. In other words, if I went looking for carbon, the most common way that I would find it would be solid and graphite. I know there's diamonds, but we don't consider that to be the elemental form. We consider graphite to be the form. If we were looking for oxygen in our normal world, normal temperature, normal pressure, it would be oxygen gas. And if we looked for hydrogen, it would be hydrogen gas, and so on. It's not on this one, but if we were looking for, say, iron, Fe, it would be iron solid, FeS. And then the other thing is what's called standard conditions, which is what we would normally experience, 25 degrees C, atmospheric pressure is 1 atmosphere. But now here's the thing that's the biggest issue, is these reactions are always written so that it only forms 1 mole of product. Now for this first one here that we're going to consider, the C3H8, if we write C3H8 and then we're trying to construct this reaction here, we would just have 3 carbons and we'd have 4 hydrogens. And things aren't that difficult. Or if we were doing it for the carbon dioxide, the CO2, we would have 1 carbon and 1 O2. Put those together, you get carbon dioxide. But here's the one that's difficult, and that is in forming water. Because if we were to take H2 and combine it with O2, so as to make H2O. This wouldn't be in balance. I've got 2 oxygens on the left, but only 1 on the right, so I'd have to put a 2 in front of the H2O. But the moment I put the 2 in front of the H2O, now I got to go back and put a 2 in front of the hydrogen. Now the reaction is in balance, but we're violating part of the requirements for a enthalpy of formation, in that we can only have 1 mole of product. So this 2 here is not going to work. You can't have a 2. So we're going to have to take this entire reaction and multiply it by 1/2, or by 0.5. So instead, you're going to get this reaction here. H2 gas plus half of an O2 gas gives me 1 H2O gas. Only in thermodynamics is it okay to have fractional coefficients, like the 1/2 here in front of the oxygen. In every other case, we'd say, oh, those have got to be integers. But when we do thermo, we can put in fractions, and that's okay. So this right here would be the reaction for forming water. And then down here on the right side is the value of the enthalpy of formation for these. But you'll notice something. For the oxygen, oops, I want to change color. Let's go with green. For the oxygen and the hydrogen, the numbers are 0. That's because they're already in their elemental form. The oxygen is O2, that's its elemental form. The hydrogen is O2, or excuse me, is H2, and it's in its elemental form. So since they're already in their elemental form, their values are 0. Now here is the, yeah, Gary. Oh, you can't see the marks. That's weird. Gary, which internet browser are you using right now? Oh, so May's not seeing it either. Okay, Gary, which internet browser are you using right now? No, he sees. Okay. Okay, Gary, which browser are you using? Is it like Firefox or Chrome? Oh, hang on a second. I think I gotta look somewhere else here. Well, no, that's not it. So, oh, the iPad might be, okay. Yeah, you got 2 things happening there that might be a problem. One is that you're using a iPad instead of a computer, and the other thing is that you're using Safari. And you'll be able to go back and look at the recording of this, and you'll see the marks. So you can look at it after we have the class. I can see it now. Okay, well then I guess we won't worry about it. But just a word to everybody, all this collaborate stuff is going to work the best if you can use a computer and if you can use Chrome or Firefox. It does not like Safari. It does not like Internet Explorer. So anyway, I know that some of you guys may only have an iPad or something. Okay. So yeah, you'd want to use a computer and use Chrome or Firefox. It's Blackboard. They're just, I don't know. Anyway, they just are what they are, and we're stuck with them. Okay, moving on though. Notice right here where it says reactions are usually not given. So when you actually have a table of enthalpies of formation, it's not going to include all this stuff in the middle. And the enthalpies of formations of elements are usually not given, so you wouldn't know these either. So what the table would actually look like is this. Sorry, that is the way it's going to work, though. You're not going to actually have those formation reactions. You're going to have to construct them if you need to know them. Many times you don't need to know them, so it doesn't really matter. But if you did need to know them, if you needed to know the one here for water, then you would have to figure out that, hey, to make H2O, it's going to be an O2 plus a half of, oh, excuse me, it's a half of an O2 and one H2. So that you only get one H2O. And then you should know that for the oxygen, the enthalpy formation is 0. For the hydrogen, enthalpy formation is 0. Everybody got it? Anybody got a question? Okay, let me see what's next here. Okay, what we're going to do now is we're going to take these enthalpies of formation and we're going to calculate the enthalpies of reaction. Now, sorry, we changed the word to heat, but heat, saying heat of reaction and heat of formation is the same as saying the enthalpy of. Okay? So anyway, this is the way that we're going to do this. To get the enthalpy for a reaction, we add up all of the enthalpies of formation for the products, and then we subtract all the enthalpies of formation for the reactants. The N and the M means that we use the coefficients. And this is the summation sign. Hopefully you guys are familiar with that. So, for example, generic reaction. We got A plus B gives us D plus E. And A has a coefficient of a lowercase a, and B has a coefficient of a lowercase b, and so on. So this is what your equation is going to look like in that case. We're going to have the enthalpy of formation for one of the products, D, and we're going to multiply it by whatever is the coefficient for D, this lowercase d. And then you do the same thing for E, and then you subtract the ones for the reactants. So over here, you've got the enthalpy of formation of A, so that's A over here. And whatever coefficient it has, you put it in here. And the same goes for the other reactant. So example reaction is C3H8, C3H8, combining with 5 oxygens to make 3 carbon dioxides and 4 waters. So we're going to start out by putting in our products, our carbon dioxide and our water. So the enthalpy of formation for carbon dioxide is negative 393.5. That was in that table before, previous slide. And those are always going to be given. You would never be expected to memorize anything like that. And then the enthalpy of formation for water is negative 241.8. And since there's a 4 here, there's a 4 here. And then moving to the reactants. Now, you see this parenthesis here and the one at the end. Well, actually, the one at the end is missing. Whoops. You want to make sure that your negative sign here applies to both of these numbers. Otherwise, it won't work right. So now our first reactant is our C3H8. Its enthalpy formation is negative 103.85. There's one of them, so there's a 1 in front. And then our next reactant is oxygen. But oxygen is in its elemental form, so the number is 0. There's 5 of them, but who cares? Okay, I'm going to erase that. And we're going to do this again. Carbon, oops, not that. Okay, carbon dioxide, a product, enthalpy of formation, negative 3.5. H2O, a product, enthalpy formation, 241.8. C3H, oops, let's change colors. C3H8 is a reactant. Here's the number for C3H8. Oxygen is another reactant. Its value is 0. So then we combine those together, and when we're all done, the answer is negative 2043.5. We're going to do a worksheet on these for some practice. But before we do, has anyone got a question? All right. Okay, I'm going to shut this one off, and I'll bring up our worksheet for this. So we've got 1, 2, 3, 4, 5. We have 5 different reactions we want to do this for. And then we have down here a table of enthalpies of formation. Now there are 2 sides to this, so don't let that throw you off. So we got one list and the enthalpies of formation for those compounds. We've got another list of compounds. We have the enthalpies of formation for those compounds. Be sure that you pay attention to things like what phase is it in. Here's H2O liquid, but here is H2O gas. It does make a difference. So make sure that you're picking the right one. And you can look at this by going into Blackboard, and that's probably the best thing to do. Let me show you where that is, just to make sure everyone can find it. So I'm going to share my desktop here with you guys. So to look at those worksheets, I'm hoping you guys printed these out, but anyway, right now I'm just going to assume that maybe that didn't happen. Well, let's start out from the beginning. We start out, we click on Course Materials, and then we scroll down to where it says Worksheets. Click there, and then scroll down some more to where it says Thermochemistry. You click on that, and enthalpies of formation is your first item. If you click there, then you're going to have the worksheet. So you might want to just do this, and then you can always click on it. Click on the tab for it and see it. Okay. Anybody having a problem finding those? Okay, looks like no one is. So now I'm going to throw that back up here again. Enthalpies of formation. There it is. Okay, I'll tell you what, let's do it like this. We'll do this first one. I'll give you guys 10 minutes, then I'll then I'll ask somebody for what their answer is. You're going to work on them in groups. Hopefully I've got everybody in their group, but let me check and make sure that I do. Oh, we got a few people that I still need to. So just a moment, I got to move a few people around. Okay, I think we're ready to go here. So I'm going to go ahead and start up the groups. Now remember, when you're in the groups, your chats and your talking is only going to be seen and heard within your group. I'm not seeing it or hearing any of it until I discontinue the groups. You guys have a whiteboard in there that you can draw on. Everybody in the room gets to draw on it. You can share your desktop with people, same as I do. So you can use that to figure out the answers. Then after 10 minutes, I'll ask a group for their answer to this first problem. Okay, you guys were warned. Your mics are all on, everybody. Anyhow, boy, they went off pretty quick. Anyway, is anybody having an issue with these things, or has it become obvious how to do it? Anybody got a question? Okay, I'm going to assume we're. Oh, yeah, yeah, much better. Yeah, that's right, exactly. As most of this stuff goes, May. After practice, it's things that seem like they're really terrible or not much. So, okay, so now let's go back to that one question that we did not do, and that was, let's see, Hess's law, and it was this middle question. Make this a little bigger, I think, maybe. Oh, too big. Well, that's not going to work. Oh, okay. So right here, we didn't do this one. What is the enthalpy of formation for acetic acid using the following data? So on this one, they didn't tell us, what the target reaction is like they did for all the other ones. So I'm going to get this started, and then I'm going to ask for some contributions from people. We'll see if this works. So it's HC2H3O2. And I'll put in an arrow. Nope, not that kind. How about, no, not that. Okay, something's going to, yeah, there we go. Okay, we don't want three of them, though. Well, anyway, you guys have got the idea there. But that's supposed to be, well, how about this? Oh, there we go. Okay, So this is the reaction, but we don't have how it's being formed. So I'm going to go around and ask some folks for what they think we ought to do. Okay. So randomly selected. Lena, what would be the first thing you'd want me to put over here on the left side? Just type it in, or you can say it, either one. Yeah, for the first one, but just first off, what kind of what kind where are we going to get one of our elements from? What kind of material? Or let me put it this way: which element you want to come up with first? I think when you said two, I think I know where you were going, but what would you want to multiply by two? Second. Don't know what you meant by that, May. Sorry. Multiply the N2. Okay, sure. Um, oh, wait a minute. There's no N2 in this. How about H2? So let's put that over here, H2. And then that's going to give you part of it. And then I'll ask somebody else. And I don't think this person is still here. Nope, they're gone. Okay, but Sam's here. Sam, what would you want to multiply the H2 by to get enough hydrogen atoms to be able to make this compound out here? How many H2s would I need? Yeah, absolutely. Okay. Thank you. No, 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 no. Don't say wait. That's good. You don't change your mind. You're good. So, okay. So we'll put a 2 out here. And I'll bring that up a little bit closer. Okay, so now we've got we got the first part of it. That's right. No kidding, Jesus. Yeah, so 2 H's is going to give us 4 hydrogen atoms, and we need 1, 2, 3, 4 of them. So now let's go for our next element that we want to deal with. Brandon, what element would you want to put in next? Yeah, your carbon. You don't get carbon as C2 though. You get carbon as a single atom. So it's going to be just carbon, and it's going to be solid. and it's going to be diamond. I mean, it's going to not be diamond. It's going to be graphite, like that. Okay, so I'll pull that over. Okay, stop it. And just realized I need to change. Well, let's see if I can just do it this way. It's getting kind of awkward here. 2H2 gases plus, and then, oh, I see what you were doing. You were wanting two of those. Okay, so I'll put a 2 in front of it. So now we just have, I'm gonna go ahead and keep going now at this point. We just need to put in the oxygens. So I'm gonna put in a plus, and then I'm gonna put in O2. It needs to be gas. Okay, so now we have our reaction we're going to need that we're trying to calculate for. So we're trying to figure out 2H2 gases plus 2 carbon solid graphites plus oxygen is going to make this compound over here on the right. So we're going to look at these reactions we have below, and we're going to figure out, how can we combine those together in order to do that. So looking at the first one there, what would we need to do to this reaction right here in order to match up with our target reaction at the top here? And I'll just ask somebody randomly here. Umu, what do you think I need to do? You can type it or say it, whichever you want to do. Looks like some people have been. You have no clue. Okay, I understand. I just realized I'm missing some chats. Okay, there we go. Well, okay. I've got HC2H3O2 liquid on the left. I want to get to H2. We want the same thing, but it's on the wrong side of the arrow. So now you remember what you do if it's on the wrong side. Umu. Oh yeah, flip it. That's right. We just take this reaction and we flip it, and then how does that change the number out here? Gary was talking about it earlier. You'd multiply it times -1, or you change the sign. So it's now going to be positive 800 and, well, that's ugly, 875. Okay, now this next one here, this next reaction, we compare it to what we're trying to match up to. We got graphite solid on the left, we got graphite solid on the left up here, but there is not the right number of them. We need 2 in the target. We only have 1, so we're going to have to multiply it by 2. Down here, I'll do the same thing 2 times. And then our last thing is our hydrogen. It's on the correct side, but we need 2 H2s. We only have 1 H2. we multiply it by 2, we can then multiply this by 2, and then we can combine those together. So you're going to take positive 875, combine it with negative 2 times 394.51, combine that with negative 2 times 285.8. We are almost out of time. Has anybody got a question in the last minute we got? Okay, I'm not seeing anything. So again, you guys be safe, over the weekend, and I'll see you on Monday. Okay? So you guys take care. Remember, this is recorded. You'll be able to get to it later if you need to. So anyway, everybody take care.